In this video, we're going to talk about properties of logarithms. We already know the definition of what a logarithm is, how it works. Properties. For positive numbers b, r, and s, where b is not equal to 1, the log base b of r times s. Anything in your argument of your logarithm has been multiplied together can be separated by doing separate logarithms and adding them together. So since you got r times s, I can do log base b of r plus log base b of s. For positive numbers b, r, and s where b is not equal to 1, if you have log base b of r divided by s, so if your argument has divided terms, you can separate those by subtracting two different logarithms. Log base b of r divided by s is equal to log base b of r minus log base b of s. If r is a positive real number, b is a positive real number other than 1, and p is any real number, then log base b of r to the p power. So if my argument has a power in it like so, I can pull the power out front in front of the logarithm. So log base b of r to the p power is equal to p times log base b of r. These are the main three laws that you're going to use when working with logarithms. So expand each expression. They want us to write this out as a sum or difference of different logarithms here. So log base a of x cubed y z to the fourth. My argument here has all been multiplied together, so we can separate it with addition, as well as the terms that have powers. The powers can be pulled out front. So log base a of x cubed y z to the fourth could be written as 3 log base a of x plus log base a of y plus 4 log base a of z. Likewise, log base b of 4w over v squared. Now in this we have 4 times w in the top, so those can be separated with addition. And then v squared in the bottom that can be separated since it's being divided, it can be separated with subtraction, as well as the power of 2 could be pulled out front. So this expansion would be 4, let's see, that's wrong, excuse me. For the first part, log base b of 4 plus log base b of w minus 2 out front log base b of v. So in the same way, we're going to expand this logarithm. So we have two terms on top that are positive, so they can be separated with addition, and then the term in the bottom can be separated with subtraction. So powers out front, 1/2 log base c of x plus 1/3 log base c of y minus 5 log base c of z. Now we can reverse the process. If I give you the expanded version, you should be able to write, using the log laws, you should be able to write these as one logarithm. So in 2 log base x of a minus 3 log base x of b. So it's log base x, we know that. In this part, the 2 has been pulled out front, so that's going to be a squared. There's also subtraction, so we know it's going to be a fractional part. And the negative term should be the one that's on bottom. So the 3's been pulled, so this will be a b cubed. So b cubed would have to be on bottom, and a squared would have to be on top, since it's the positive term. Log base b of x minus 6 log base b of y plus 3 log base b of z. So any negative term will be on bottom, so this middle term is going to be on the bottom, y to the 6th. So we're going to have log base b of, let's see, on the bottom we'll have y to the 6th. I need to put that in parentheses, it just looks better. Okay, and then the terms that you have on top would be an x because it's positive, and then z cubed because it's